This is g3g, and in this lesson we're talking about all of the polygons, like a trapezoid, a kite, and pentagon, hexagon, so on and so forth, all the special polygons. And especially we're going to focus on these theorems, which I got from the theorem list. And we're going to take a look at a few problems that can use those theorems. Here's an example of a kite, and in this kite we're supposed to figure out what the measure of that angle is inside the kite. Well, what I'm going to do is I'm going to copy this shape out right here. I'm going to make it nice and big right here. And this is 25 degrees. And the thing that we're supposed to remember is, and from the theorem list, is that these diagonals in a kite are perpendicular, which means that this is a right angle, which means that 25 degrees and 90 degrees plus the angle we're looking for, what should they add up to? Well, this is a triangle, and all the angles in a triangle add up to 180 degrees. And so in this case, it's 25 plus 90 plus 65 degrees would add up to 180. So that angle would be 65 degrees. So that's an example of using the theorem about the diagonals in a kite. Let's take a look at a second example. In this second example, we have a regular hexagon. Hexagon has 6 sides. And I'm going to take one of the sides and I'm going to extend it. And when I extend it, it makes an exterior angle. So what would the measure of that exterior angle be? And so one of the theorems is that if you keep extending all of the sides of any polygon, regardless, that total of the exterior angles is always 360 degrees. So how many exterior angles are there in a hexagon? Well, 1, 2, 3, 4, 5, 6, just like the number of sides. So I divide 360 by 6, and that means the measure of my exterior angle is 60. And the last thing I should mention is, how do I know that they're all exactly the same? Well, that has to do with this word right here. It's a regular hexagon, so all the angles on the interior are the same measure, and all the angles on the exterior are as well. So that's the second example of how to use one of the theorems. This time it was about the exterior angles in a polygon. The last example, I have a drawing of a pentagon, and inside this pentagon there are 1, 2, 3, 4, 5 angles. And what we want to know is, what would the sum of all 5 of those angles be? Well, from the theorem list there is a formula, and that formula is n minus 2, that quantity, times 180 degrees. And so what n stands for is the number of sides. In this case, since it's a pentagon, would be 5. And this formula applies to all polygons, so the number of sides you plug into this formula, and it will tell you what the sum of the angles are. So 3 times 180 degrees equals 540 degrees. There's one other thing I should tell you about, and that is a special case where if it's a regular polygon, which means that all the angles are exactly the same measure and all the sides are the same length, then you could actually divide this number by the number of sides, and that would tell you what the measure of each angle is. So if this were regular, each angle would actually be 108 degrees. But again, that only works in a regular polygon. Alright. Again, here are the 4 theorems, And if I could offer some advice, I would know these left and right, back and forward, as you are to know, prove, and apply these on the end of course assessment.